All right, so I haven't finalized midterm number 4, the exact question, but there are two hints I want to give it to you. First, if you recognize this on the right-hand side was the inheritance hierarchy for your midterm number 3. So with midterm number 4, this is recorded, so you can take a look at. We add another one, which is to follow the idea of MT4. MT4 thing, of course, is midterm number 4 instead of midterm number 3. Locatable, holdable, and then we have a shadow thing on the side. So essentially, the shadow thing will allow us to accomplish whatever we want to accomplish with the CPP09, which is the shadow object. Okay, so instead of shadow GPS, now we're doing shadow thing. So pretty much this side, the code is change or just change from MT3 to MT4, but we will give you also the code related to shadow thing, both .h and .cpp file, and then for you to answer some question and then provide some analysis on the code based on the concept of CPP07, by the way, 06, 07, 08, 09. There's 4 directory. There will be similar style of coding. You will see that in this exam from midterm 3 to midterm 4. And the other thing I wanted to say that, I mean, I really appreciate a few of you come to my office hour yesterday. We actually discussed some of the concept that will be covered for midterm number 4. So particularly, I emphasize on the 3 level of concept. The first level is for virtual function. It's a language issue feature. And the second level, what's the term I was using? Is the transparency or hiding of the locality. And that was the second issue, such that you're worried not just about syntax, but you worry about what is being perceived by the programmer. Especially we're looking at the difference or the function interface between the remote procedure call. JSON RPC, when we want to make a call, in the example we use over there is dump to JSON. What is the difference between the function signature, which affect the transparency to the programmer regarding the function itself? And then we talk about this kind of shadow object, which is essentially allow you to establish and build out that. Okay, so that is what we would like to cover in the midterm number 4. So 2 things. One, I hope you can just realize that that's the style. That's the exact inheritance hierarchy. You will be answer question for midterm number 4. And also the video that I recorded yesterday for the office hour provides some kind of clarification for some of the questions I'm going to ask you on Friday. Okay, so take a look at those recent video and particularly look at CPP 06, 07, 08, and 09. Those 4 directory are going to be the focus of this coming. I'm not guaranteeing everything. I'm going to ask everything because you guys only have 50 minutes. I cannot ask you more than 4 questions. Usually 3 questions, 1 with 2 parts. So it's totally, I can only ask you 4 questions. So I have to be selective which 4 I'm going to include it in the final version of the midterm number 4. Okay. All right. So I'm going, let me see. How do I get all of this? Okay, I want the end of the show. All right. So I want to continue with the concept of JSON to object, which is a CPP 010. So let me go back to the function prototype. The example I use is GPS. Oh, I should actually remove this file. I don't need this file anymore. And I'm going to go to the object directory and remove label I'm going to remove this two objects so I can show you the test. Okay, so this is a CPP010. It's already uploaded on GitHub. The important thing, we will continue to work on this. This is probably one of the, I consider one of the most important concepts you will learn this quarter is combining a lot of things we're learning, except multiple inheritance. I want to reserve multiple inheritance exception for the last. Exception is very important. It's my focus for your final midterm, the midterm number 5. But multiple inheritance is really something which my experience, if you can avoid, you should avoid using multiple inheritance, especially with C++, because the concept is different from your understanding about multiple inheritance in another programming language, such as Python or Java. That's why. But this one will include all the single inheritance, all the JSON RPC, all the encapsulation, all the idea about casting, putting together. So I'm going to first continue what we talked about last time. So let me go to gps.h. So I present to you one particular new function, which is complement to the dump to JSON. So it's a two-way street. Dump to JSON is converting a C++ object into a JSON representation. While the whole thing about CPP number 10 is the second function called JSON to object, means that the other way of the street, which is converting from a JSON to a C++ object. So this is a two conversion such that you can bridge your program with a lot of other interesting programming language or very interesting application. So I'm going to present you the first one. I call it persistent object. So last time I emphasized that up to this point, when you write a program, you want to create a bunch of objects, and then once you terminate the program, your objects are gone. So those objects we call transient object, means that it will temporarily survive in your program when you're executing, and once you clear your memory, your object is gone. All right. So this is obviously not ideal for a lot of practical application. In practical application, we want the object to be persistent. So to be persistent, which means that I can finish this program, I create a bunch of objects, I want to save it somewhere, and then next time I can either resume or restart the program, I can bring those objects very conveniently back. Okay, so which means that I need to have a way to store the object somewhere. Obviously, storing the object, we could store on the file. Or actually, later I will show you, you can store on a remote server. For example, Google, so you can use RPC to store the object on the other server. Okay, like the Dropbox, those kind of situation. So in order for us to store an object, we have to decide what is the format that we're going to put it in the hard disk or whatever storage device that you have. And I emphasized last time, to store the object as what they are in the memory is not the ideal solution for C++ object, because in C++ object, you have a bunch of pointers. For example, it's not just the pointer you have within your object definition, but the pointer you have implicitly, such as a vtable pointer. That's actually already in there. So if you think this object is 256 bytes, you try to store from the first byte, which is the pointer to the object, and the next 256 bytes. And then you will realize you store a few bytes, at least meaningless, because those bytes represent pointer that's pointing to the vtable for a particular class. And the thing is that when you rerun this program, the vtable where you store the class, like for example, function, member function pointer, and those things related to the vtable, they're likely to be store in a different location. You can actually check this out. By the way, up to this point, you should feel comfortable to write a little bit twist to print the address of the V table, print the content of the V table, such that you run this program twice or 3 times at different time. You should observe the address should be different, because that is being allocation depending on how your memory is used. So we're saying that if you want to write the content to the as it is in the memory to the file, is probably not going to be ideal. I'm not saying you cannot do that. You can, by the way. If I somehow really understand this part of the V table, I can just get rid of it and restore that. That's fine. But it's not really natural to do that. And the second thing is that when you store in the file, that file is not readable. Okay, for example, you want to debug. You want to actually check what it is, or you want to display that persistent object to a web interface to allow people to read it, and the memory doesn't give you anything nicely. So the ideal choice that we use is using JSON. So JSON, in fact, is designed to represent an object in a neutral way, in a language neutral way, I should say that. So such that any kind of object you can use JSON to represent, just like the question number 2 I asked you for the midterm number 3. The way I emphasize that is you can use that language, very simple syntax. You can represent any kind of complex object in a line of bytes and then represent, it's readable, by the way. If you use a 2-style string to print it, it's readable. So what we want to do is we want to be able to do that, to write that JSON and then save in a file. So then what is a JSON to object is try to read it back, to read the JSON from a file. And then once you have the file, you can convert it back. Okay, that's what I'm going to show you. So let me first show you how this works. And then we're going to look into the code, how you should really implement this function JSON to object. So in this directory, CPP010, okay, I'm generating 2 executable. One is called test write, one is called test read. So test write is try to convert the JSON object to a file, where test read is convert from the file to the JSON and then to the C++ object. And then we can see what kind of object we're dealing with. Okay, so I'm going to do first doing the test write, but I want to show you what the test write is supposed to do. So you can take a look at this. In test write, I use this example, object 1001, which is a label GPS object. I create with the 3 argument with the longitude, latitude, and the label, which represent, that is the address for, that was the GPS coordinates for Costco in Woodland. Okay, so I'm going to print it, just tell you what the content it is. And then what I'm doing is, you can see over here, I invoke this line. So this line is, I convert the object, which is object 1001 is what? Is a C++ object. So I use dump to JSON. I actually write it to another JSON object. I call it JSON object 1001. So now I have 2 objects. One is the C++ object. I call the object 1001. I probably should use a CPP object 1001. Now I converted JSON 1001 using dump to JSON. And then look at what I did. I create a file name. I create a subdirectory called objects. And then I create another file name called label GPS 1001. So you have to decide what kind of file name you want to store that object. So I call it label GPS 1001.json. And then you see I use this function called myJSON to file. MyJSON to file, and then put the file name pointer, which is defined over here, which is really the path object / label GPS 101. And then I put a pointer or reference to the JSON object. So essentially, my JSON to file is writing the JSON to the file. And then, of course, there is some kind of a check I need to do whether that's successful. If it's a successful, that's it. Okay, I'm just checking the return code whether it's equal to 0 or not. Okay, I can tell you what more about my JSON to file. But this program overall is doing very simple thing. I have a C++ object. I decide what's the file name I want to store this. I convert it to JSON and write that JSON to the file. That's what we're doing. So let's try to run this program. Okay, it's already done. So let me tell you what I had. This directory, there's nothing. If you look at the object directory, there's nothing. Okay, inside this object directory, there's nothing there. So I'm going to run the program. So once I run this program, it says that, okay, I wrote the wrote the JSON object to label GPS 101.json, and this object is 104 bytes. Okay, I write 104 bytes over there. So now let's look at ls objects. Now you can see that I create a file. And this file is labeled. By the way, this is output of dump to JSON for the same object. And now I look at this. What is this label GPS? Let's do this. More objects, label GPS 101. If you look at the content is identical. So essentially, there's nothing magic, right? I'm having a C++ object. I use this function I already defined called dump to JSON, and I produce that, and I just essentially write it to a file. And the file name is called label GPS 101. Okay, so essentially, now I store that particular object in the JSON format under a particular location I decide. Okay, so that's what we do. So we already do the one-way conversion, convert from C++ to JSON, and convert to a file to support the persistency. All right. Any question? Okay, so now let's take a look at the read part. Okay, the read part is very similar. Again, I create by the way, I do create a JSON value, which is ready for me to receive the data from the file. And you can see that I create a JSON value for JSON object 1001, but that JSON is empty. Okay, when I do that without anything, it's an empty JSON. Okay, just declares JSON, but I know what's the file I want to have. So that's why I'm using the file name pointer, try to say, okay, this is the file, I try to get to that. But look at this function I call. Now I'm using another function. The function I using test_write was my JSON to file. So now I'm using the opposite file called my file to JSON. My file to JSON essentially is given this file name, I will retrieve the content and then parse it and then put it into the JSON object 1001. By the way, one thing that you will ask, what is my file to JSON? What is JSON to file? The important thing, the most tricky part about file to JSON is that I want to check, the program needs to check whether the content that's being stored by the file is indeed has a valid JSON syntax. Okay, so let me tell you a little bit. That file, by the way, is included here. So now you can see there is a program I included in this CPP10 for the first time, but this is called ecs36b JSON.cpp. Okay, it is basically include how we're going to handle the JSON to the file in using C++. And let me just show you what the program is very quickly. Okay, there is a bunch of files, but I want to first go to my file to JSON. Okay, you can take a look. This is the file that's just like the file I use in test read. It takes the file name, it take JSON. And then let's go over here. You see that inside here, if you actually be able to get the everything correctly, you use the file to, so it's actually two steps. The first step is just take the file and store into the string. Okay, so instead of directly try to convert it to a JSON, the first thing I want to take the file. I mean, when you take the file, you go into the string, usually that has no problem, okay? Because a file is a string, it's just a bunch of bytes. So I'm first calling my file to string. That function is also defined in the same file. And once you've done that, see what I did is I need to check the syntax. So I do my parse to JSON. So let's take a look. Where is my parse to JSON? Okay, so inside here is my parse to JSON. My parse JSON is a little bit more complicated, but this is the very standard part of the code. You just basically follow the JSON CPP style. You essentially build a class called builder, and then it's called reader. That was also an object. And then inside the reader, you do the parse function. So if you, in fact, this quarter, you don't need to understand the detail about how to do my parse JSON. But if you're interested, my parse JSON is there. In fact, I don't expect you to know anything other than know how to use my file to JSON and my JSON to file. Essentially, if you include ecs36b JSON.cpp, you already have all the source code. Later, if you're interested to know the detail about how this thing, by the way, this file is not that big, okay? It's just a bunch of code that you can use it to help you to know the detail. But the real important thing is that, sorry, what did I do? The real important thing is my file to JSON. You should know how to use this, not worry about the detail about this. And also know the other program called my JSON to file. Okay, my JSON to file is what we use in tests, right? And then this is the function you will be calling. Okay, so those two functions are both under ecs36b underscore JSON. Okay. What happened? Did I? Okay, I'm glad I'm still being recorded. Okay, that's good. Okay, so now let's go back to ECS test read. So test read, I call the function my file to JSON, and then it will return a return code. RC usually in the C and C++ program stands for return code, because sometimes my file to JSON will encounter a bunch of error. The first kind of error is that file doesn't exist. I tried to open the file, but that file doesn't exist. I'm not going to get a valid JSON if the file doesn't work. And the second error you will get from my file to JSON is that, well, that is not a JSON. When you store in the file, it's not. So there is a bunch of check that my file to JSON is going to check to make sure if RC is equal to 0, that means everything is good. You can continue to use this JSON object. But if you have anything goes wrong, it's going to return either -1, -2, -3. You can take a look at the source code to see what kind of error it will catch up. Later, we will teach you how to use exception. And now this time we're just using return code. So essentially, for C programming, we do a lot of return code, which is for error code. For C++, we start to use this kind of exception. And using exception to do the same thing, but looks it's actually handle things better, in my opinion. Okay, so this is just try to convert it to a JSON. So now finally we go to our main course, for this part of the program, you can see that now I have this JSON. So this JSON is essentially represent a valid JSON object from the file. Okay, now let's take a look at see. Remember what is object 1001? Now I create object 1001. This is a C++ object, but it's empty. I didn't have any initialization. So this one is a label GPS. I call the object 1001, but it hasn't been initialized at all. Okay, so now you can see what I did is I did an object 1001 dot JSON object. JSON to object. So essentially what I did is I converted the JSON representation back to C++ representation. And after I done that, I actually just check whether the object 1001 has all the things I expect. So that's why I can actually call now object 1001 dump to JSON to see what you get. So you can see that we're kind of converted back and forth to check everything is doing well. I haven't told you how to do JSON to object, but I want to first tell you at high level, the usage of these two functions, dump to JSON and JSON to object. For the application of persistent, I want to emphasize these two functions, JSON to object, object to JSON. They're not just for persistency. There is a lot of interesting application I will tell you next time. But at this moment, let's just worry about the persistent object, okay? All right, so let's try to run this part. Okay, I don't need to do that, so I just run test read. So you can see that when I read it, it's reading this object / label GPS 1001. Fortunately, that file is there, so I can continue to polish the object, and then I do a dump to JSON. You see that information is being nicely presented as we expected. So I kind of complete the process of going from C++ to JSON to a file, and from the file back to a JSON, and from the JSON back to the C++. Okay, this is just a simple example of how you can use this intermediate format to really convert it back and forth. And then you can see that the test read is a program essentially reload the object you store persistently. Now I can continue to do whatever I want, okay? Any question before I start to look at the implementation of JSON to object? Okay. Right, so now let's take a look. So first I want to take a look at GPS part. Okay, so under GPS.h, so in fact, you need to have this virtual function for every single class that you want to implement the kind of functionality such as persistency. So first, I declare a virtual function like what I did, okay? So virtual bool JSON to object like this. Okay, so now let's take a look at the GPS.cpp. Okay, so this part is the program. You can see that the function prototype is a Boolean GPSDD JSON to object with a lot of things. So I want to clarify the input argument for this JSON to object is a JSON because I want to convert it back to the object. And the return is a Boolean because I want to see whether this conversion is successful, which means that a lot of cases it will not be successful. Okay, so let's take a look at that. This code, you will see that the real code to do this conversion is very simple. It's at the end. You can see that here. What I did is this. I only explain one line. You will see why it's so simple. So essentially, I want to extract the latitude attribute from the JSON and convert it to the C++ latitude, which is a double. So take a look at what I did is, what's the input argument? It's a JSON. So I'm expecting, because I know this is GPS, I'm expecting under this JSON, I need to have an attribute called latitude. So I use this to extract the latitude, but I also know that whatever value I can extract from JSON must be a double because the type has to be the same. So I basically take it out and then dot as double. Okay, by the way, in JSON, you have a bunch of functions like such as double or as int or as string or as object or as bool. Okay, you can use a lot of this type. So essentially, this line is doing is first extracting the latitude from the JSON object, and then interpret the value as a double. And then you assign that double value into this attribute latitude. And then similarly, you do longitude. You use the longitude key to extract the JSON value. And then you interpret that as a double value using the function as double. This, the whole thing over here is a double, if successful. And then that double got to assign into this longitude. So in this case, your GPS object has both latitude and longitude assigned as the value I converted from JSON. Okay, before I show you whatever before that, let's take a look at label GPS code. Okay, over here you see it's the same thing. This last line is the same thing. What is the label? In the label GPS, it's a string. It's not a double, it's not an integer, it's a string. So you can see that I extract from the JSON object, I said label. I want to use the key label to extract the JSON value, but I want to interpret that JSON value as a string. And then that string is going to assign to the label. So you can see that this reline essentially tries to put the value appropriately from the JSON representation back to the value I expect with the type in the C++ object. So those three lines is really doing the trick. Well, there's a bunch of questions you should ask at this moment. In order for me to run this line, this label, the first thing is what happens if I don't have this label attribute? I mean, for example, when you corrupt the file and such that you let's actually do a little bit trick here. Let me do a little bit trick here. Let's go to object. And I actually going to modify this object here. And then take a look what I did. I changed this to label. Instead, I said L1. Okay, I've just modified the label. Now I'm going to run my read, test read, sorry. You can see that, sorry, I have to go back one directory. Okay, so now you can see that I have an error in the JSON2 object. Why? They realized that one of the attribute doesn't exist. So that's why when I convert it, I cannot completely convert it back to a label GPS. So I'm missing that label attribute over here. Okay. All right. So let's go back to here. Let me go back to the GPS. CPP. So essentially, what I'm saying is that I cannot just expect, this is a very different. Yes. Okay, that's a good question, right? So number one, whether there is an attribute, whether that particular attribute can be converted to a double or converted to a string. Excellent question. So we have a bunch of check, but I want to show you what I did over here. You see that here, I'm going to two parts of check. The first part and the second part. The second part has, you see that has another function called isDouble. So essentially, now I lost, I think I remember I had a good conversation with another student on Monday. is that what is the difference between handling JSON and handling C++? There's a big difference. In C++, I rely on compiler, helping to check the syntax. But in JSON, I don't have really a compiler for me to check. So I have to do all kinds of check myself when I'm the converter, doing the same thing compiler doing, but at runtime. So let's see what kind of check I did. Okay, the first check I'm going to check is whether this particular JSON object is a null object or not. Because I'm expecting to be a real object, so it cannot be null, and it has to be an object. If it's not an object, it's not a null, then I'm going to stop. So by the way, what do I mean by a JSON is an object? So essentially, when you look at a JSON could have a few things. First, it could be an object. So the object must be started with a pair of a curly bracket. That is an object. The other potential is an array. Array, it must start with a pair of a bracket. So when I include a JSON that's purpose for JSON to object, I'm expecting it has to start with a curly bracket. So that's what I'm checking. Number one, it cannot be null. If it's null, I'm in trouble. I don't want to deal with this anymore. But it has to be an object as well. So if it's a null or it's not an object, I'm going to return false immediately. Don't do anything else. But now I'm actually looking at the latitude and longitude. You can just see that the first two lines, I'm checking whether you have an attribute called latitude at all. If I want to do a GPS object conversion, if you don't have the latitude and longitude, I'm going to stop immediately. I'm going to return false as well. That means you're not doing this successfully. Okay, so I'm going to do ARG latitude is null. If this is equal to true, I'm done. Basically, that's error. So now I go back to what's your name again? Devin asking, well, how do I know it's a double? You don't know. We have to check. So the way to check is that if I can reach this line, that means it must exist, right? Means this one, because I don't know if you know C++ programming, the first condition fail, it will jump out of this 4 parts check. Okay, so if you can reach this line, that means your first 2 lines must both be false. Okay, so you can reach over here. So over here, you can see that I know the latitude it is there. So I extract the latitude, and then I will use this is double. Is double is check whether it has. So essentially, I do this for every single attribute. I want to check every single type. And then if this is not true, if it's mean that it's not a double, I'm going to return false as well. So that's why when I get to here, I know, number one, the attribute latitude does exist. No power, sorry. Can you hear me? Okay, I will have a lot of this kind of voice enhancement drop tonight, okay? So I will speak louder now. All right, so number one, the latitude must already exist. Number two, it must be a double. So I can call as double. By the way, sometime if this is not a double, you try to convert to a double, this will cause a runtime error. Okay, so that's a JSON way of handling things. So based on this, you know that, okay, I did. So that's why JSON to object, essentially you did a lot of check almost everything, and then you do a little bit of things putting to there. Okay, of course, when the object get complicated, this might get complicated. For example, if the object has an array, I will show you next time an array. For example, you have a bunch of things. How do you actually do that? It's just adding a loop, but the basic logic is the same. You're going to check that whether that's an array, you're going to check for each of the array, whether that has the right key, the right index, and then has the right value type. And then once you're doing this, you can actually just convert this way. Okay, this will help you to reconstruct the whole object. So any question for this one? Okay. I'm going to take a look at the label GPS. Okay, in the label GPS, it's similar, but I'm going to use my inheritance relationship a little bit different. So the first thing is I know that this label GPS has a part related to my parent, which is a GPS. So you can see that the first thing I did is I tried to convert my parent. So you can see that this is a virtual function, but I force it to call the parent version. Remember, virtual function, you can do this. I just say this to the GPS underscore DD and the JSON to object. It's going to force it. Forget about virtual function. It will call the parents virtual. But why I do that? Because I want to extract the GPS part of that conversion. So this one, if successful, is going to give me both latitude and longitude. So the only thing I need to do is about the label. So you can see I'm still doing the same thing. I'm actually check whether you do have a label available. If you don't have the label, like I converted to L1, it's going to give me a false. That's why I got that arrow in the previous example. And then the thing I check whether this is a string. Just like I say, that this is double because I know this is a string. So I have to write the code, say this is a string. And then I said this is as string. Okay, and based on this, I essentially have the full implementation about JSON to object. Okay, any question? By the way, one thing I have never done, I'm not sure anybody have done this automatically. It is actually possible to automatically generate this piece of code based on a .h file. If you have a .h file, you should be able to generate both dump to JSON and JSON to object automatic, just like what we did with JSON RPC. But so far, I haven't seen people doing this for C++. Okay, so if you can generate the code, then this part will just automatically produce all the check based on the program you have. Okay, that's something which, as a programmer, usually we have two ways to do it. One is just write the code ourselves, but the other one is just try to generate the code. Okay. Okay, I think this is a good time for me to stop for this sequence of lecture. I just wondered, do you have any question for either today's lecture or for midterm number 4 on Friday? Yes, please.
So is this lecture is not included for this upcoming midterm, right?
It is not, except the first few minutes. I kind of give people some hints. No, the inheritance hierarchy. So it's everything under CPP 09 to 06 to 09, but this is CPP 010. Okay, but I just want to show people again. This is the inheritance hierarchy for midterm number 4. You will see this diagram in homework 4 and with the code as well. Okay, I just want to tell you. So it's the same concept, but instead of using GPS object, which is one type of object, I'm using the thing locatable, holdable, like what you learned from other contexts. Okay. Any other question? All right, so I will stay here for a while, and if you have any question, let me just close it. And I will